heading into the middle of the Atlantic now because we're going to look at one of the most famous shipwrecks of all time, the focus of all those documentaries and Hollywood movies. But there's one version of Titanic we have never seen until this morning.
For more than 100 years, the world believed the Titanic was ripped open by one enormous tear that caused it to sink within minutes. But a groundbreaking 3D reconstruction created nearly 3,800 meters beneath the Atlantic has completely challenged that story. Built from over 700,000 ultra-detailed photographs and nearly 16 terabytes of data, this astonishing digital replica reveals something entirely different. Instead of one massive rupture, researchers found 6 narrow openings stretching across almost 300 feet of the hull, pointing to a much longer and more violent breakup than history has taught. The scan also preserves evidence of extraordinary efforts made by the engineering crew that likely saved countless lives while placing key artifacts exactly where survivor accounts claimed they would be. If Titanic's final chapter has been misunderstood for over a century, what other secrets has the deep ocean been keeping from us? Capturing this level of detail was anything but simple. The expedition spent 3 full weeks at sea, documenting every visible part of the wreck. Each morning before sunrise, 2 remotely operated vehicles named Romeo and Juliet descended into the darkness, disappearing beneath the waves to begin another painstaking mission. But before we uncover more of Titanic's forgotten secrets, subscribe to the channel and turn on notifications, because beneath the waves, history is still waiting to be discovered. Nearly 3,800 meters below the surface, the environment is unimaginably hostile. Water pressure there reaches almost 400 times that experienced at sea level, turning every dive into a true test of engineering and human determination. Carefully guiding the vehicles through mangled steel, collapsed decks, and towering piles of twisted wreckage required constant focus. Using sonar systems and laser guidance, operators maneuvered through extremely tight spaces while avoiding hazards that could trap or destroy the expensive machines. Even with powerful lighting systems, visibility remained poor. Thick darkness and clouds of disturbed sediment constantly limited what the cameras could see. Ocean currents shifted without warning, forcing pilots to make continuous corrections. One wrong movement could leave an ROV tangled in cables or crushed beneath unstable sections of the ship. Surveying the wreck demanded incredible precision. Rather than making a single pass, the team scanned the site repeatedly in carefully planned, overlapping patterns. Every photograph needed to overlap by at least 60% with the next one, ensuring that no section of the wreck was overlooked. Romeo and Juliet crossed the debris field again and again, sometimes waiting hours for suspended sediment to settle before capturing the next series of images. The imaging equipment was specially engineered for deep-sea exploration. Custom-built low-light cameras, synchronized with powerful flash systems and precision laser markers, recorded every surface in remarkable detail. Each image was automatically linked to its exact location and capture time, slowly assembling an enormous digital puzzle made up of more than 700,000 photographs. Back on the research vessel, engineers worked non-stop between dives. Saltwater steadily attacked electrical connections, crushing pressure stress protective housings, and freezing temperatures threatened sensitive electronics and battery systems. Despite these relentless conditions, the equipment continued performing throughout the mission. By the expedition's conclusion, researchers had collected almost 16 terabytes of raw information. Every rivet, every bent steel plate, and every scattered artifact had been documented with millimeter-level detail. What once depended on decades of estimates and interpretation could now be recreated with forensic-level accuracy, opening the door to an entirely new investigation into Titanic's final moments. Once the final ROV returned safely to the surface, a different challenge began. Inside the expedition's control center, photogrammetry specialists faced an immense archive containing more than 700,000 precisely tagged images. Their first task was to eliminate photographs affected by drifting sediment, poor lighting, or accidental obstructions, leaving only the highest quality frames for processing. Advanced software then began identifying matching details between thousands of photographs. Rivet patterns, portholes, fractured steel plates, and countless other recognizable features were aligned one by one, allowing the computer to reconstruct the wreck in fully detailed three-dimensional form. To ensure exceptional accuracy, the researchers used both artificial calibration markers placed around the wreck and permanent reference points already present on the ship itself. Serial numbers stamped onto the propellers, along with precisely measured boiler components and other known dimensions, allowed the software to scale the model with astonishing precision, reducing measurement errors to as little as 1 or 2 millimeters in the clearest sections. Areas filled with heavy shadows or especially complicated structures required additional verification. Specialists manually inspected those regions, comparing multiple scans to remove distortions. Any image producing inconsistent measurements was automatically flagged, and entire sections of the model were processed again whenever quality standards were not met. To further confirm the results, laser scanning technology worked alongside the photographic reconstruction. By projecting a precisely measured grid across the wreck's surface, researchers could compare laser measurements with the photogrammetry model, revealing even the smallest shifts or distortions, and ensuring the final digital replica reflected the Titanic with unprecedented accuracy. Every section of the wreck, from the intact bow to the shattered stern, including the vast debris field and the engine spaces, underwent rigorous quality verification before becoming part of the final model. Nothing moved forward until every measurement met strict accuracy standards. The finished result was far more than an impressive visual reconstruction. It became a highly reliable digital twin that historians, engineers, and forensic investigators could trust for detailed analysis and permanent historical documentation. With the reconstruction complete, researchers gained something never before possible: the ability to revisit Titanic's final hours piece by piece. Every damaged rivet, every twisted steel plate, and every artifact became another clue in rebuilding the disaster with remarkable precision. The digital twin paints an extraordinary picture of the ship's resting place. Nearly 4,000 meters beneath the Atlantic, the wreck stretches across a silent landscape of steel, sediment, and darkness. The bow remains remarkably upright, its sharp prow still pointing forward as though it were continuing its journey toward New York. Resting gently within the seabed at roughly 3,800 meters, it appears to have settled with far less violence than once believed. About 14 meters deeper lies the stern, almost beyond recognition. Instead of retaining its original shape, it has collapsed into a chaotic pile of torn decks, shattered machinery, and crushed compartments, evidence of the tremendous forces unleashed during its final descent. Connecting these two massive sections is a debris field extending nearly 600 meters. Thousands of objects remain scattered across the ocean floor, preserved by freezing temperatures and crushing pressure. Massive engine components lie alongside delicate porcelain dishes, worn leather shoes, broken furniture, and fragments of the ship itself, each resting exactly where the sinking left them more than a century ago. Using survey-grade measurements, specialists mapped every section of the site with exceptional precision. The bow and stern rest on a slight underwater slope, with their positions and depth differences calculated down to mere millimeters. The bow's relatively shallow position suggests it entered the seabed gradually, allowing the soft sediment to absorb much of the impact. The stern tells a completely different story. Its deeper resting place and catastrophic deformation indicate it plunged downward while spinning violently. Structural failures, combined with overwhelming water pressure, ripped it apart before it finally slammed into the sea floor. The distribution of debris provides another powerful piece of the puzzle. Heavy machinery, boilers, and massive steel beams remain concentrated near the stern, while lighter belongings, including suitcases, wooden fragments, dishes, and personal possessions, were carried farther across the seabed by ocean currents and the tremendous forces generated as the ship broke apart. By studying these debris patterns, investigators can trace how the ship's remaining energy dispersed during its final moments. Some objects drifted gently to the bottom, almost untouched, while others were thrown with incredible force, breaking apart upon impact and creating dense clusters of wreckage separated by long trails of scattered metal and personal belongings. This detailed map represents far more than an engineering milestone. For the first time, investigators possess a complete forensic layout of Titanic's final breakup on the ocean floor. Every shift in depth, every concentration of debris, and every structural fragment adds another layer to the story, preparing researchers to better understand both the mechanical failures and the human experiences preserved within the wreck. Among the countless artifacts is a small child's shoe, roughly size 8, resting quietly on the seabed. Its leather has hardened with age, yet the outline of its tiny buckle remains visible after more than a century underwater. Not far away sits a damaged trunk, its contents spilled across the surrounding silt. A comb, a hairbrush, several coins, and other personal belongings frozen in time. Because of the new digital reconstruction, these objects are no longer isolated discoveries. Each can now be linked to a specific location aboard the ship and connected to the sequence of events that unfolded during the evacuation. In the remains of the third-class accommodations, bunk frames have been flattened beneath enormous pressure. Their distorted shapes match the exact areas where the hull folded inward as seawater rushed through the damaged compartments. Outside the engineering spaces, investigators found electrical control panels bearing clear signs of extreme heat. Copper wiring remains fused together, while scorched insulation still clings to surrounding structures. These are not merely damaged components, they serve as silent evidence of the desperate struggle that continued deep inside the ship as disaster unfolded. Researchers even traced the journey of a single deck chair from its original position on the boat deck to its final resting place hundreds of meters away. Though cracked and splintered, its curved wooden frame remains unmistakable. Likewise, a child's shoe, once thought to be an unrelated artifact, now aligns closely with the evacuation timeline of a family last reported near Lifeboat 14. Many survivors recalled seeing Titanic's lights shining long after the stern had begun rising into the night sky. Remarkably, the new scan supports those memories. Burned insulation, damaged electrical wiring, and evidence of electrical arcing throughout the upper sections indicate that the engineering crew managed to keep power flowing until almost the very end. Historians have worked alongside the mapping specialists, comparing these discoveries with survivor testimony, family records, and passenger documents passed down through generations. One heavily damaged trunk, recovered near the stern, closely matches an entry from the passenger manifest. Although its owner has never been definitively identified, the personal belongings inside strongly suggest it belonged to a young woman traveling alone. For many descendants, discoveries like these offer something priceless, a connection to loved ones whose stories remained incomplete for generations. The digital twin does far more than preserve the wreck itself. It preserves the memories of the people who sailed aboard Titanic, ensuring that their final moments are remembered with greater clarity, dignity, and understanding than ever before. Titanic's final story is no longer just a tale of steel and tragedy. It is a story connected to real lives. Every mapped artifact and every damaged section of the wreck adds another piece to the human and mechanical puzzle. The digital twin reveals that Titanic's famous unsinkable design had a critical weakness. Its 16 watertight compartments were separated by steel bulkheads, but those walls did not extend high enough. Once the iceberg created 6 narrow openings along nearly 300 feet of the hull, water moved from one compartment to the next, flooding over the tops of the barriers like a staircase. The scan confirms that Titanic's failure was not caused by one single flaw, but by a chain reaction of design limits, flooding, and structural stress. The ship slowed the disaster, but could not prevent it. The digital model also challenges old myths. Titanic's small rudder and massive size meant it could not turn quickly enough after the iceberg was spotted. Studies show the response was simply too slow. Material tests reveal the hull steel and rivets were typical for the early 1900s. The breakup pattern was not caused by brittle metal alone, but by the combination of impact, stress, and flooding forces. The scan also sheds light on the rescue mystery. The Californian was farther away than legends suggested, surrounded by ice and darkness. Meanwhile, evidence from damaged electrical systems confirms Titanic's crew kept lights and communication running until the final moments. Now, with the digital twin complete, engineers can create the most accurate simulations ever made. They can test how water moved through the ship and even explore alternate designs, such as whether taller bulkheads could have changed Titanic's fate. For the first time, Titanic's final moments can be studied not through rumors or legends, but through data, evidence, and a digital recreation of the wreck itself. Along with these virtual experiments, researchers are preparing new deep-sea searches for missing sections of Titanic's midship area. Using advanced chirp sonar and sub-bottom profiling, teams hope to detect hidden fragments buried beneath layers of sediment. The digital twin now acts as a precise guide, directing ROVs and sonar missions toward locations where lost pieces of the ship may still be waiting. For the first time, computer simulations and real-world exploration can work together, creating a new chapter in Titanic research based on evidence rather than speculation. The complete Titanic digital twin has also been opened to the public, revealing every visible rivet, deck beam, and artifact captured during the expedition. The massive 16-terabyte collection includes high-resolution images, laser scans, and navigation records, transforming the wreck from a protected mystery into a global research resource. Scientists, historians, and educators can now study the wreck in unprecedented detail, measuring hull damage, tracking artifact locations, and comparing survivor stories with physical evidence. Researchers are already using the model to revisit historic investigations and test long-standing questions about the breakup, lifeboat positions, and the final moments of the ship. The Titanic story is no longer frozen in the past. It has become an open investigation where experts and citizen researchers can continue discovering new details. The scan has rewritten the final moments of Titanic. Instead of one massive tear, the ship suffered a slow and devastating breakup through 6 narrow openings stretching nearly 300 feet. Evidence now supports survivor accounts that the lights remained on until the end, while the engineering crew fought to keep power running for as long as possible. With the digital twin, artifact database, and future deep-sea missions, Titanic is moving from legend into measurable history, revealed through the wreckage, the data, and the human decisions made on that unforgettable night in 1912.